let's start with big omega notation. So this is a capital omega or big omega we can call. So when we call capital omega notation or omega notation, it gives a greater than or faster rate. So as what we have discussed in big O, it was like giving upper bound and slower rate. So now it is lower bound or faster rate. Lower bound or faster rate. So now you can see using big omega notation we can calculate minimum amount of time which is required for one particular algorithm. So what was happening in big O notation, it was like the maximum time it was giving, and whatever algorithm execution time or algorithm complexity was always falling below that. But now in this case, big omega notation, we can say that algorithm complexity will be minimum this much and will always be higher than this particular value. So it is like the formula what we can write is f of n is always greater than or equal to c into g of n, where n is greater than or equal to n0, c is greater than 0 and n0 equal to 1. So now where c is a constant and n is a function. Now let's as we discussed, it is a lower bound or best case big scenario, and let's discuss this. So now with respect to graphical notations, what we can say, we have a notation called f of n which is moving something like this. So now we can see that c into g of n is this notation, and now f of n, like I'll just take a different color for f of n. So now as f of n is moving, you can say it is intersecting c into g of n as 2 to 3 points. So now at first point we can say that c into g of n is greater than f of n. But so as we say, c is into g of n is growing faster than f of n and f of n is going slower. But now after this point, these two intervals, f of n is growing faster than c into g of n. Now these next two intervals, again c into g of n is growing faster and f of n is growing slower. But now after this point, what we say n0 point, after this n0 point, c into g of n is always less than f of n. That means f of n is growing faster than c into g of n after the point n equal to n0. So as what our equation suggests, f of n is always greater than or equal to c into g of n for n greater than or equal to n0. Also we need c greater than or equal to 0, or c should be greater than 0, not equal to 0, or greater than or equal to 1 we can say. So let's see the example. So now g of n equal to, I'll just take n plus 2 I will take, and so f of n equal to 3n plus 2, g of n equal to n plus 2, and let's take c equal to 2. So now what we have is f of n which is equal to 3n plus 2, g of n into c is 2, so we can get 2 into n plus 2 which is equal to 2n plus 4. So let's go on calculating the values and see how this omega notation works. So for n equal to 0, we are getting f of n equal to 2 and c into g of n is equal to 4. Now for n equal to 1, we are getting 3 into 1 is 3 plus 2 is 5, and here 2 into 1 plus 4 is 6. Then n equal to 2. So for n equal to 2, we are getting f of n equal to 3 into 2, that is 6 plus 2 8, and 2n plus 4 is 4 plus 4 8. So now at this point, we got f of n is equal to c into g of n. And now let's go ahead with further values. F of n equal to 3, we will be getting 3 into 3 9 plus 2, that is 11, and here 2 into 3 6 plus 4 10. If I put f of n equal to 4, 4 into 3, that is 12 plus 2 14, and 2 into 4 8 plus 4, which is 12, it is 5, 3 into 5 15 plus 2 17, and 2 into 5 10 plus 4 14. So now we can see that as we go on increasing n after this, we are getting f of n is always greater than. So now in this case, whatever example we have taken, f of n is always greater than or equal to c into g of n for n greater than or equal to 2. So now how our graph will look? Our graph f of n is 3n plus 2 function. So for, let's say, if this is n, and for n equal to 0, this is also intersecting at point 2, and g of n is also intersecting at point 2. But now 3n plus 2 will have higher slope compared to this one, right? So I'll just draw sorry, c into g of n is actually now c into g of n, which is equal to 2n plus 4. Okay, so now our 3n plus 2 line may look something like this, let's say, and we have this line where second line, that is, this is f of n, and now the second line, that is c into g of n, that is 2n plus 4. That may be something like this, because after intersection point 2, so at point 2 they both lines will get intersected. So I'll just take it this way, and I will draw a line which is having little bit slower slope. So you can see that after n equal to 2, f of n is always higher than 2 into g of n, because here's 2 is c, so I'll write c into g of n. So this is our capital or big omega notation. Okay, it's actually capital omega notation.